Welcome back, guys. This is question 2.10 and the statement of this question is find the total power developed in the circuit in figure P2.10 if V naught is equal to 5 volts. So this is figure P2.10 and here the value of V naught is given, that is here, and the value across it is 5 volts. Okay, so that is the voltage which will be here and here as well, because if we see all of these are basically the common ones, so therefore these are in parallel. Okay, so these three branches, this one, and this one, all of these are in parallel with each other, so therefore the voltage will remain same across them. So here, in order to find the values of the power developed across everyone, we have the formula, that is P is equal to IV, means I should know the value of the current which is flowing through that source and the voltage which has been developed across that source. Okay, so here we have different sources. Here this is the voltage source, the value of the voltage is known, while the current value which is in this branch only, that is known, and that is 9 volts. Okay, similarly here in this source, which is the current source, the value of current is known while the value of the voltage is unknown. So let me call it here plus minus VB, and we have to find it out. Okay, here in this branch the value of the current is again known, and that is 6 ampere because of the availability of this current source, while the value across it is unknown. Okay, we have to find it out, and that is V of A. So what do we have to find out? Let me write it here. We had to find out V of B. Here VB, VA is also unknown, which is here, and the value of VG, which is unknown because the value of current is known while the value of VG is unknown, and also the value of V naught, that is already known. Okay, so let us first find out the values of VB, VA and VG. In order to find the value of VB, what do we have to do? We have to apply the KVL here in this branch. Okay, so we know the total voltage here, and that is 5 volts. Okay, in order to find out the value of the unknown voltage here, we have to apply here the KVL, Kirchhoff's voltage law. So here it will be what? It will be, let me write it here, it will be what? It will be VB plus 20, that is equal to 5. Okay, so in order to find it out, we will get here VB is equal to, this will be there, so it will be minus 15 volts. So therefore the answer of this VB is minus 15 volts. Okay, so that is known now. In order to find the value of this VA, which is here, we know that here in this source the value of V naught is equal to 10 VA. So V naught is equal to 10 VA. Okay, and the value of V naught is known, that is 5. This is 10 VA, sorry, this is VA, so that is VA, and from it we can very easily find the value of VA, that is 5 divided by 10, or that is 0.5 volts. Okay, so the value of this VA is also known, and that is 0.5 volts. Now to find out the value of this VG, again let me use the KVL here as well, and in this branch the KVL here would be what? Here this all is known, and that is 5 volts. Okay, because of around this branch which is here, and let me write these voltages. So VA is this positive, negative, so let me take it positive 1. Okay, and let me write this VG, that is minus VG. Okay, so let me write their values. So 5 is equal to VA, the value of VA is known, and that is 0.5 minus VG. To find the value of VG, we have here 0.5 minus 5, so it will be, the value of VG would be minus 4.5 volts. So therefore this is minus 4.5 volts. Okay, so these quantities are now known, we have found them out, and now we can very easily find out all the values or all the powers across them as well. Okay, let me now clean it. So now let us start it from this source, which is here 9 amperes. Okay, so let us start it from this one. Let me use this color here. So this is P9, and in order to find the value of the power here, the formula is this one. The value of current through it, which is 9 known, and the value of voltage, which is VB, so that is minus 15. Okay, so P is equal to IV here. So 9 multiplied by minus 15 is minus 35 watts. Okay, and this negative denotes what? It means that this current source basically develops the power of 135 watts. Similarly, this 20 volt source, so here the current through it is known, and that is 9, and the voltage across it is 20. So this is now what? This is 180 watts, and the sign associated with this one is positive. It means that this one is the absorbing source. Okay, now let us move here, and this 6 amperes, P6 is what? The current through is 6 multiplied by the voltage across it is 0.5. so this is 0.5, and that is 3 watts, and plus sign denotes that this is the absorbing source. Okay, now this VG, let me call it PG, and the current through it is known, that is 6. Okay, and the voltage across it is minus 4.5, which is already known. Okay, one thing you have to keep it in your mind here, that if this one is minus 4.5 and the value here is 0.5. Okay, so if we apply here the KVL, we will see that the value of it here would become what? It will be minus 4. Okay, which is not possible because of this 5 volts. So in order to maintain it, because this will have to maintain the voltage of 5 volts here, it will, the actual value of the current will be in the opposite direction as that of here. So therefore it should be the negative one. So here the current here, the opposite one as that of here. So it will be what? It will be the 27 watt, and this positive sign denotes the absorbing nature of this source. Okay, so now all of these are known. In order to find the power associated with this source, what do we have to do? We know the value across it, that is 5 volts. We don't know the value of the current which is passing through it. So let me have here this current, let me call it I0. It reaches this node and splits into two parts. Let me call it IA, or let me call it IB, and here IA. Okay, so according to the KCL here, I0 is equal to IA plus IB. Let me put their value. So the value of IA is 6, the value of IB is 9, so this is 15 amperes. Okay, so in order to find cross it, let me call it P0. So P0 will be equal to 15, which is I multiplied with the voltage, which is 5 here. So it will be what? It will be the 75 watts. Okay, but here keep it in your mind that as this is the dependent source, so therefore the actual direction of the current should be inwards, not outwards. So therefore the current, if this is inward, so it will be minus 15, so it will be minus 75 watts, which is the developing power. Okay, so this is one method. Another method is that in this overall circuit, the value of the developed and the absorbed power should be equivalent. Therefore here let me use this color here, P9 plus P20 plus P6 plus PG and plus this P0. This should be equal to 0. All of these values are known except this P0. So let me put them here, minus 135 plus 180 plus this P6 is 3 plus 27 plus P0, that is equal to 0. Or here adding them all together, we will see that it will be 75 plus P0 equal to 0, which will ultimately give me P0 equal to minus 75 watts, which also shows the developing nature of this dependent source. Okay, so this is the developed power and this one is the developed power as well. If we add them together, the total power developed PD, and that would be P naught plus P9, so this will be minus 210 watts. Okay, because this P naught is minus 75 watts, this P9 is minus 135, so adding them together we will get minus 210, and that is basically the solution of the question which is asked. So that's it for today. If you have any question in your mind, please ask me in the comment box. See you soon.